this when we do arithmetic. And we would get x is 16. So we've identified the unknown number. Now what's algebra, what we typically call algebra, is we switch x around. We'll say something like this. There's a multiplication is implied there. And so we got to try to use some techniques to discover that x is 5. And we've been working on them. We've developed situations where if we're adding something or subtracting something from x, how we can find x. We've done things like this. So what we do is we do the opposite. Instead of subtracting, we add. These will cancel because we're doing the opposite thing. And that leaves us with x equals 9. And we have to add 2 to both sides, because what we do to one side, we have to do to the other. And so we've been solving equations like this. So what I'm going to get into today is something a little more complicated. So let's say we have something like this. So what do we do with this type of equation? And the thing is, what I'm asking, do we try to, I'm just making sure you can see this. Do we try to reverse or cancel the 2 or the 3 first? Which do we try to do first? And so when we're dealing with this kind of equation, we want to undo addition or subtraction first. Then undo multiplication or division. So we want to undo the addition or subtraction first, and then undo multiplication or division. What we're basically doing is PEMDAS backwards. So usually with PEMDAS, we do parentheses, then exponents, and then multiplication and division, and then addition and subtraction. But in this case, what we're going to do with PEMDAS, instead of doing the typical approach, we're going to go backwards. I'm going to say solving for x. So what this means, I'll give you an example, then we'll solve this equation. So usually with PEMDAS, what we do. Usually, we would calculate this first, then we would do this second, and then we would multiply third, and then we would do our subtraction fourth. So we do it in the parentheses first, then we would do the exponent, then we would multiply, and then we would subtract. But let's say we're solving for x. Would make this an equation. Well, when we're solving for x, we undo the subtraction first. So that's the first thing we'll undo. And we do that by adding 3 to both sides. Then we'll undo the multiplication. We do that by dividing by 5. In fact, let me write this a little differently. Our second undo. We'll divide by 5. This will be our first undo. We'll undo it by adding 3. This here will be our third undo. To undo an exponent, we have to do what's called a square root. And we haven't talked about that yet, but we'll talk about that later. And then finally, our fourth undo. We finally get to undo what's in the parentheses. And we do that by subtracting 1. So this can get a little complicated, but basically, if you're comfortable with PEMDAS, you can just say, well, I'm going to undo things in an order where PEMDAS is reversed. We're going to undo what PEMDAS did. Now, the simple way of doing this is just to remind yourself that when we have to choose between addition and subtraction or multiplication and division, we take care of addition and subtraction first. We take care of multiplication and division second. So that's the simpler and probably the more accessible way of dealing with this. So once again, I'll reiterate. We'll undo addition, subtraction, and then we'll undo multiplication, division, and then I'll put this one here too. Then we'll undo parentheses. So we'll follow this order. So let me do some examples to show you what I'm getting at. So let's go back to that one equation we started with. So I'm giving you a bunch of sort of like, well, this is what we're going to do, but like, how does this really work for homework and stuff like that? Let's go back to this one. (3x minus 2 is equal to 10). So we have a choice between subtraction and multiplication. We want to undo subtraction or undo multiplication. We're going to do the subtraction first. We'll undo that first. And the way we undo subtraction, we use addition. And so we get 3x is equal to 12. So any questions about that? Next, what we're going to do is we'll undo the multiplication. So we divide because division is the opposite of multiplication. And what we're left with is x equals 4. And that's going to be our answer. So any questions about that? So let me do another one. Now let's say we have something like this. Now we have a multiplication, and then we have addition that's in parentheses. Now, thinking about PEMDAS, we usually do parentheses first and then multiplication. What we want to do is do this backwards. We want to undo multiplication and then undo what's going on in the parentheses. So first, we'll undo the multiplication. So we can divide both sides by 5. And when we do that, we'll get x plus 1 is equal to 2. I'll keep the parentheses here. But now, as we're going through PEMDAS backwards, now we'll undo the parentheses. Now we can drop the parentheses because we're now going to do the calculation inside. We're going to reverse that. what we're going to get is x equals 1. So any questions about that? Now, there's another way of doing this problem. I want to go through that method too. And this is kind of an interesting approach. But what we could do for an alternative method is we can distribute. We can take the 5 and distribute it to the x and to the 1. And that'll give us 5x plus 5 is equal to 10. And now we can go through and do our PEMDAS backwards, or order of operations, if you will. Order of operations would say do multiplication and then do addition, but we're going to undo everything. So we're going to undo the addition and then undo the multiplication. So to undo the addition, we subtract 5. We'll get 5x is equal to 5. And then to undo the multiplication, we divide. So we get x is equal to 1. So any questions about that? All right. So there's another thing that comes up in these problems, and it's something like this. Let me see, let's go back. Let's say we have a problem like this. Now, what we've done so far is that we've had x on one side, and we just had to sort of dig up x, reverse the subtraction or addition, then reverse the multiplication or division, and then reverse the parentheses. And as we keep digging, we sort of recover x. What we've basically been doing is we go from the outside in. But in this situation, we've got something else. So what we do in this one is we start out by distributing. Because we have x on two sides, we're not sure really how to undo any of these x's, how to dig them up. So let's just get everything distributed first. Now, we're still in that same mess. Are we trying to uncover this x, or are we trying to uncover this x here? So what we want to do, let's get the x's on both sides, on one side. We want 1x on one side. So the way we're going to do that is we're going to move one of those x's. And the way we do that, we subtract 3x from both sides. And so this will cancel the x term on this side. It'll leave us with just one x term on the other side. So we'll get 2x minus 1 is equal to 15. So now we're on familiar ground. This we know how to solve. So we have 2x minus 1 equals 15. We undo addition and subtraction first. So we get 2x is equal to 16. And then we undo the multiplication. And we get x is equal to 8. And that's going to be our final answer. So what I'm going to do, I'm going to put a problem here on the board. And I'm going to give you just about a minute or two to try to solve it on your own. And then I'm going to go through it. And we'll take a look at the answer. So let me give you about a minute or two to work on this. And then we'll go through the answer. And then after this, we'll look at formulas. We'll look at some formulas from, I think it's 1.1. Let me see, did they give you any in 1.2? No, not 1.2, but look at some from 1.1. Now, just for the sake of time, I'll give you about another minute or so. You'll go one more minute. One more minute. All right. So what we're going to be looking at, let's distribute. This is the easiest way to deal with this. So we distribute the 3 and distribute the 4. Now, if we do that, we're going to get 12y minus 3 minus 5 is 12y minus 8. Now, negative 3 and negative 5, they're going to combine to negative 8, 12y minus 8. And we can move the 12s over, get the y's on one side. So this will cancel, goes away. But what's going to happen on this other side? 12y minus 12y. Well, that's 0. So we cancel it here, and we've actually ended up canceling it over here. And so we get negative 8 is equal to negative 8. Now, this is sort of an unusual answer. But what we're going to say is this. This is always true. And when you get this kind of an answer, what we're going to say, the solution is all real numbers. So we did everything right. Another way this is done in XYZ homework, and let me show you what this looks like. Let me see, they might answer it. Let's take a look. What they'll sometimes do is have you answer infinity, which isn't quite correct. They'll sometimes want you to answer with infinity. The way they do that in XYZ homework is O, O, with no spaces. So it's 2 O's. They'll have you answer it like that in XYZ homework. Now, there's another kind of situation you might get. So let's solve for x in this case. We'll distribute first. We'll get 3x plus 30. We'll move the 3x over. Try to get the x's on both sides. On one side, sorry, one side. And we're going to get something like this, which is kind of surprising. Because this isn't true. 4 is never equal to 3. So when we solve an equation and we get something like this, what we've basically done is we've been given an equation that's not valid. And so a non-valid equation, there's no solution to it. So what we put down is no solution. So questions about that? Something else, another example that comes up, it's more of a format or a notation issue, but it's something that's kind of good to be familiar with. Let's say we have this. Now, what we do in this problem, this minus sign, we treat it like it's a -1. We can treat it like this and then distribute the -1 like that. But what we can do a shortcut. And the shortcut is this. Distribute the minus. We're going to distribute the minus. So what that looks like what's going to happen is that anything that's positive, like 4 times -1, will become -4. And then you have a double negative. -1 times -1, +1. Now here, we're going to gather like terms. Remember that x by itself is the same as 1x. So if we gather like terms, we'll get 1 minus 4x plus 1 is equal to 7. So 1 minus 4, that's -3. So you get -3x plus 1 is equal to 7. And this equation, now that we simplified things down, we've distributed this minus sign, we've gathered like terms, And now we're in this equation. This we know how to solve. We're going to do PEMDAS backwards. We'll undo the addition and then undo the multiplication of -3. So we undo the +1 by subtracting. We get -3x is equal to 6. And then we divide by the -3, and we're going to divide by the minus as well. We include that minus. And so what we'll get is x is -2. There we go. Yeah, I know I had some storms yesterday, and that knocked out my internet for about, I think, 10 seconds or so. So the internet connection can be a little fuzzy when you have the storms coming in. And then let's see, another example that would be good to do. Let's say we have this. So again, I'm going to recommend distributing. Now, in this case, we're distributing the entire thing, the -2. We're going to distribute the sign as well. So this whole thing will be distributed. So we'll get 6x plus 2 is 8 minus 6x minus 2 times 1 is -2. And again, the way you could think about this, I'm just going to put this sort of in these little brackets that mean, here's a note. 8 minus 2 times 3x plus 1. We can think of that as 8 plus -2 times 3x plus 1. We can think of it like that. And again, it's that idea that subtraction can be rewritten as adding a negative. So that's essentially what we're doing here. This is just a real nice shortcut. We'll just remember to distribute the minus and the 2. But in the background, this is what we're really doing. And the -2 times 3x, -2 times 1. So now we're going to combine. And here I'll write this again. So if you wrote that note down, you would write this below the note. So I want to get the 6's on one side. Or not the 6's, but the x's. And so we have 8 minus 2. Now this we can combine. That's going to be a constant value. It's going to be 6. And so what we're going to do here, again, we're familiar ground. We're going to work from the outside into x. We're going to undo this and then undo that. Now the 12 here, they're going to cancel out. But 4 divided by 12, 12 doesn't divide into 4. So this is going to become a fraction with 4 over 12. Now, the last thing we want to do is we want to reduce. So we can break this down into prime factors, or if we want to take a shortcut, we might realize that 12 is 4 times 3. And since 4 would be repeated in the bottom and in the top, these will cancel. Now, because they're canceling, there's nothing in the top. We got to put in that placeholder. We got to put in that 1. And so our answer is 1/3. So questions about that? So that's pretty much it for 5.3. Just want to do some examples there. That should cover pretty much the types of equations that you're going to encounter in the homeworks. The next thing, section 2.4, we're looking at formulas. And what a formula is, it's an equation with more than one variable. Now, formulas are kind of tricky in that regard, because if you have more than one variable, like 3y plus 1 equals 2x minus 7, you could solve for x, but there's going to be a y over here. You could solve for y, but there's always going to be an unknown number x over here. So if you try to solve for one variable or the other, you're always going to have the other variable hanging around. So you don't get a number in the end. And this is kind of a problem. Like, you know, you can solve an equation for a variable and discover what variable or what number is represented by the variable only if you have one variable in the equation. Like it's x's or it's y's. But when they're in there at the same time, we really can't solve. I'll give you an example if we try to solve this. Let's say we're going to solve for y. We'll cancel the 1. And now we're going to undo the multiplication by 3. Now, again, we're actually dividing the entire side by 3. And so what that's going to give us is y equals 2x minus 8, whatever that happens to be, over 3. So what happens with a formula, if we solve for one of the variables, the answer will be in terms of the other variable. And that's kind of a problem, because we were hoping to get a number on this side, but instead we get a variable. So that's one of the tricky things with formulas. And we're going to come back to this in a little bit, because we're going to solve for variables in formulas. But first, what we're going to do is we're just going to use them. So this is covered a bit in section 1.1, but we have this idea called perimeter. And the idea of perimeter is this. Let's say we have a rectangle. It has a length. It has a width. Now, for rectangles, the perimeter is L plus L plus W plus W. Now, what perimeter is, it's the distance around a 2D shape. It's the distance around a 2D shape. That's perimeter. So what we can do is we can simplify this a little bit. We can gather like terms. And so the way we gather like terms, we have two L's. So we'll just call this 2L. Then we have two widths or two W's. We'll call this 2W. And so this is the perimeter formula for the rectangle. So let's do an example. Let's find the perimeter of a rectangle with width 5 feet and length 20 feet. So what we're going to do, and we'll get into story problems more later, but we're told that the width is 5 feet and the length is 20 feet. So what we're going to do, we'll go back to our formula. We'll replace the L with 20 and the W with 5. We're going to do something like that. So the key thing is we're doing what's called substitution. We talked a little bit about this before with algebraic expressions, but just to bring it back, substitution. As we replace a variable with a number. That's substitution. We replace a variable with a number. And when we do that, it's convention to put parentheses around the number that's we're doing the replacing with. So what's going to happen here? We have 2 times 20 and 2 times 5. So 2 times 20, perimeter is 40 feet plus, and then 2 times 5 is 10 feet. And then 40 feet plus 10 feet is 50 feet. And so that would be our solution. Now, we could have a problem like this. Find the length of a rectangle with perimeter 100 and width 25. Find the length of a rectangle with perimeter 100 and width 25. Well, let's go back to our formula. Now, we've been told it's a rectangle. That's important because the perimeter of a rectangle has a very specific formula, namely this one. So we're told the perimeter, that was 100. So P is 100. And then we were told the width, that was 25. So we can multiply these two. Now, when we do that, we get 2L plus 50. And so we're solving for length. We want to find the length. So we subtract 50 from both sides. Again, undoing the addition before we undo the multiplication. Finally, we undo the multiplication. Look at 25 is equal to L. We get a length that's actually the same as our width. That's a special type of rectangle called a square. And interestingly, a square has its own perimeter formula. It works for the square, but won't work for the rectangle. But the rectangle formula also does work for the square. So kind of an interesting back and forth there. So you could get something like this. Now, the other shapes from section 1.1 that we looked at for perimeters, you want to know. And I moved the homeworks for 1.1 and 1.2. They're due tomorrow. Those are going to be due tomorrow. Let's say you have a square. Well, a square, the sides are the same value. So again, with perimeter, it's the distance around the shape. So to figure out that distance, it's like if you walk along here, then walk along here, walk along here, and then walk back to where you started. And you add up the distances as you go. S plus S plus S plus S, or P, if we gather like terms, P is 4S. And so that's the perimeter of a square. So what typically happens with squares is you'll be given, say, one of the sides. And they'll tell you that it's a square. Like say this is 7 feet. And that's important because you can have a rectangle that's just slightly a rectangle, just barely. You want to know if the sides are exactly the same. So the perimeter is 4S. So again, we've got two variables here. For this to work, we got to know one of the variables. And they tell us one of them is going to be 7 feet. So we do our substitution, and we get 28 feet. And that's going to be our answer. Now, the other shape that we use formulas for is the triangle. And the triangle, for computing the perimeter, if this is side A and this is B, C, this is a length, this is a length, and that's a length. Well, you add those up to get the perimeter. Well, that's what you're going to get. Perimeter is A plus B plus C. And that's it. That's the best we can do. It doesn't reduce down to or simplify, or we can't combine any like term because each of those lengths could be different. So for example, let's say the triangle that's 20 feet on one side, 17 on the other, and 14 on the last side. Well, the perimeter, the sum of the three sides, are 20 feet, 17 feet, 14 feet. That'll be 37, 47, or 51 feet. And that's going to be our answer. Questions about that? Now, there are other formulas, area formulas, that are for these shapes also. And area formulas, what area is, if perimeter is the distance around a 2D shape, area this is the space inside a 2D shape. It's the space on the inside. So each of these shapes has their own area formula. So for the rectangle, we're given a length and a width. The area is length times width. For the square, it's a variation of the rectangle. As a square, they typically label one side. But the area of a square is the side square. And you could think of this being an S here, S here, S here. Then length times width will give you S times S, or S squared. And then the triangle, now this one's a little tricky. We have our sides A, B, and C, but we need one more measurement. The height, H. And usually what will happen with the triangle, we're going to relabel some sides here. We'll call this whole thing B. We'll call that A. When computing the perimeter, it doesn't matter. You're always going to add up all three sides. But typically, we refer to this bottom one as B. And we call it the base. The area will be 1/2 the base B times the height. So I'll do an example with the triangle. Let's say 6 kilometers. 4 kilometers. We'll go 3 kilometers. And then we need the height. The height of this triangle, 2 kilometers. So to compute the area is 1/2 the base times the height. Or 1/2, the base is 6 kilometers. And the height is 2 kilometers. So as we do these calculations, 1/2 times 6 is 3, or half of 6 is 3. And 3 times 2, well, that's 6. Now here's something important with area though. Area, the units are not going to be kilometers. That's only with length. But area, the units are kilometers squared. Or what you might see in XYZ homework, 6 square kilometers. So area will always be in units squared, or square unit. So any questions about that? So something that comes up with formulas are solving for variables. And we saw this at the very beginning of the discussion of this section. We had an equation with a y and an x in it. We solved for y, but the solution on the other side of the equal sign still contained an x. So for example, let's say we're going to do this. A equals B plus C, solve for B. So what we're going to do, we're going to treat B like it's the only variable, and we're going to treat the other variables as if they're constants. And that means we're going to move or cancel them. That's what that means. We're going to move or cancel the other variables. But we'll treat B like it's the only, as if it's the only variable. It really isn't, but we'll treat it that way. So what happens when we do this? We want to get B by itself. So it's got this C here, so we want to cancel this C. So we get A minus C is equal to B. Now the C's will cancel here. Now we don't know though, A and C, we don't know their value. So all we can say is that we're going to subtract C from A, and someday someone will come along and tell us what A equals and what C should be, just like with algebraic expressions. And then we could find a number representing B. But until that day comes, that's the best we can do. Questions about that? Now let me do another example. Now again, we want to get V by itself. Now, to get V by itself, we have V times a T, and then we have this added to this thing. So what we can do, we can cancel this entire piece. And so the way we're going to do that, we'll subtract 16 T squared from both sides. Next, the thing to do is divide both sides by T. Now we're dividing the entire side by t. And when we do the subtraction of the 16t squared, we're actually subtracting 16t squared from this entire side and also from this entire side. It just looks like we're subtracting it from this term. But really, we could just, it might be better to write it like this. We're subtracting it from the entire side, but then these are like terms. They're going to combine and cancel. So it always looks like we're subtracting it from one term, but we really aren't. We're really subtracting it from the entire side. So if we follow that, we divide this entire side by t, well, the t is going to cancel out anyway. But then on this side, we'll get h minus 16t squared over t is equal to v. And that's going to be the answer. Let me do one more example, and then that'll be it for today, and we'll get ready for lab. Solve for y. Oof, there's fractions in there. Everybody's favorite. So what we're going to do here, we want to solve for y. So we want to kind of dig up y as best as we can. So we can think of this, and with these large fraction bars, there are implied, we have implied parentheses. So we can think of this as y minus 1 divided by x. So the opposite of division is multiplication. And again, we're going to undo what's outside the parentheses first, and then deal with parentheses last, the opposite of PEMDAS. So that'll leave us with y minus 1 is 3/5 x. And we can add 1 to both sides. We'll get y 3/5 x plus 1. Now, there's a shortcut way of doing this. Let me show you that real quick, and then that'll be it. The shortcut way of doing this is, instead of rewriting it in this long division form, not long division, but what we typically do is, once we're comfortable with the idea that there's parentheses here, and then we do the division, if we follow PEMDAS, well, that means we need to undo the division, and then we get to work inside the parentheses. So what we typically will see people do, and it might be a little sloppy, but it's a shortcut. If we're dividing this entire thing by x, we multiply the entire thing by x. So these will cancel. We'll get y minus 1 is 3/5 x. And then add 1 to both sides. We'll get y 3/5 x plus 1. And that's going to be your answer. So that's section 2.4. So what we're going to do, we're going to switch over to lab unless you have any questions, and I'll wait here for about a minute or so and make sure no one has any questions before switching over. And then that's pretty much it. So we'll have some lab work. I'm still getting caught up on the lab work. I'll let you know about that as soon as I can. And then we'll go from there. I'll have some lab questions. Use the time to work on the homeworks. And any questions about those homeworks, I'll be here to answer them. And don't forget, I've put out my office hours. So office hours that are available. And I'll be doing office hours this evening, I think from 5 o'clock to 7 p.m. Yeah, that's the time, 5 to 7. So if you have anything, click on the office hours under the start here, and we can go over homeworks, even work on homeworks together if that would help. So other than that, that's it. So I'll see you in lab.